Okay, so looking at worksheet 1, questions 1 through 12 ask you to simplify. So this is a combination of several of the different properties that we talked about on the other page. And of course, some of these are easier than others. But what I'd like to do is give you 5 minutes to read all 12 of those questions and answer the ones you think you know. And we'll go over, make sure that you actually do know the ones you think you know, and then I'll explain how you're supposed to get the other ones. Of course, also try to do these without the notes. The notes is kind of a backup when I'm not here, but just kind of a first glance, see what you've got. Okay, last minute. Okay, so definitely kind of one of the frustrating things, if this is something that, logarithms ends up being a struggle for you, your friend, your neighbor could probably answer these questions if they know what they're doing in like 60 seconds. Like, there's not much work to be done, but if you don't know those properties that we talked about on the notes, there's really not too much that you can do to move forward. So I can't emphasize that enough. Also, as I go over these, any that you didn't know, the property you didn't think of, or the mistake you made, you really need to give yourself a note or highlight that. You need to learn from your mistakes. Honestly, the best way I think you could learn this is if you just did 50 of these type, and 50 of those type, and 50 of these type, and 50 of these type, and just do a ton of drill, and then you couldn't help but memorize those properties. But of course, that would be a bit tedious, so we don't make you do that. But number one, well, first let me go over the answers, so then you get an idea of how many you got right. Looks like number one should be 7, number 2 should be 8, number 3 should be x, 5, 0, 5, -2, 0, -2, 1, 5, and 7. Now again, I'm not doing any special tricks, but I'm able to answer those that quickly just because I know the properties I need to do. So please follow along and fill in the ones that you were not able to get. Number one was that property, if you have an exponent on something that you're taking the log of, you can bring the exponent down out front. And then log base 2 of 2 is saying 2 to what power gives you 2. So that was just comes out to be 1. And then 7 times 1 is 7. So seeing how to deal with that exponent. What you don't want to do, although I guess it would work, 2 to the 7th, you could ask yourself 2 times 2 times 2 times 2 times 2 times 2 times 2 is what? And then ask yourself 2 to what power gives you that number. But that big number is going to be hard to do in your head. Okay, number 2, this is the property that says if you've got a number and its exponent is log of the same number of something, that just equals to something. 3 and 3 were the same, so 8 was the answer. Okay, number 3 is a lot like number 1. Exponent on something that you're taking the log of can be brought down out front. And then the natural log of e is 1, because natural log means log base e, and so this is saying e to what power gives you e. That's how I knew that was x. Okay, some of these things you get to reuse a lot too, by the way. If the natural log of e is 1, then over here, the natural log of e is 1. 5 times 1 is 5. This one was asking e to what power gives you 1? E to what power gives you 1? And that would be 0, because anything to the 0 power gives you 1. Number 6 is a lot like number 2. Same property. I got a number e. Its exponent has a log base e of 5, so all of that just equals 5. That same property. I can't really show you in any more steps. It just fits that pattern. Number 7 is probably the most missed one in past years, so I'll put a star by that and come back and do that one a little bit slower. But number 5 and number 8 are basically the same thing. This is saying 10 to what power gives you 1? 0. Anything to the 0 power gives you 1. Number 4, number 9 looks similar. Natural log of e is still 1. -2 times 1 is -2. This is base 10. 10 to what power gives you 10? That was how I got 1. Number 11 looks like number 1. 5 is an exponent on something that I'm taking the log of. So the 5 can come down out front. And you're left with 5 times log base 4 of 4, which is 1. And number 12 is the same pattern of question 2 and question 6. I've got a number its exponent has a log, its base is the same number of 7, so the whole thing is 7. That property. Then back to number 7. This would be similar to what I did for you in your notes with exponent rules. This is the same thing as this. Bring that to the other side of the fraction, make it negative. Bring this down out front. Negative 2 times the natural log of v is negative 2 times 1. So, considering using an exponent rule before you bring it down. Okay, so if you glance at worksheet 2, the first 12 questions are very similar, so you need to try to learn from these and then maybe use those 12 practice questions, not right now, but use those kind of as a practice quiz. We will ask you the same things. I think I said like 5 times in there that the natural log of v is 1, so you should expect that one to be a big one. If you don't know that one, then you've removed yourself from getting 5 or 6 questions correct. Some things are just come up more often, but you can do these, you can certainly do those. Okay, moving on. The next section says solve. So let's look at how to solve these. We do much more difficult ones near the end of the unit, but all of these are kind of rigged where they should just use the properties. Okay, so what could we do in question 13? How could we simplify that to solve? Yep.
Log 6 of 6 is equal to 1.
Okay, and so as long as you know how to evaluate that, add 1 to both sides, divide both sides by 3. So I will highlight the only thing that was new, knowing that that was 1. The rest was just solving like you'd solve any other equation. Okay, somebody else? Question 14, how could we rewrite some of this to solve?
The first half would be just 8.
The first half is just 8, because that fits that property that was in question number 2 and a couple others. And now that we have it written like this, well, hopefully we can do this in our head because it's a nice whole number. 2 to the first is 2, 2 squared is 4, 2 to the third is 8. But knowing that equals 8 relies on you knowing that property. If you don't know it, you're pretty much done at the beginning of the question. Okay, number 15, I'll just tell you this one. We've done a couple of these. If this is natural log of some stuff and that's natural log of some stuff, to make these equal, we just need to make sure that what we're taking the log of is equal. Set them equal to each other, and then solve like you would normally solve. Add 6 to both sides, subtract 3x's from both sides, x is 6. Now, for the sake of accuracy and to reduce careless mistakes, and sometimes it's going to be necessary for extraneous answers, you really should want to plug this in and make sure that you're not taking the log of a negative number. This would be natural log of 18. Plug this in, this would be natural log of 18. So the left side certainly equals the right side, and I'm not taking the log of a negative number. Okay. I would like you to try to do the same thing on number 18. 15 and 18 look like they have the same setup. so wasn't that pretty easy?
Yeah. Actually, I think it's 16, but the rest should be easy.
Well, I just was talking about 18 so far.
Oh, for real? Okay.
If log base 10 of this is supposed to equal log base 10 of that, you just need to make sure the thing you're taking the log of is the same. So x would have to be 3. That gives you log of 6 on the left and log of 6 on the right. I think 17 is going to be the difficult one, but we'll talk about that. Okay, for 16, all right, well this, well, I don't see much we can do with this yet, but this is a little harder to evaluate, but you can change all of that to just a number. So 2 to what power gives you 1/2? -1. That's one of those exponent rules. A negative exponent in the numerator is the same thing as a positive exponent in the denominator. So you have to do that step to get to here. And now this doesn't just work well in your head. You still need to be doing some algebra here. And the algebra that I would suggest to you is you'd say, all right, this is hard for me to do in my head because there's logs out here. Well, the log's out there because it's in logarithmic form. If that's a problem for you, switch it to exponential form. If you want to remove this, you just switch these two around. This is the same thing as a half. Now divide both sides by 3, and you get a 1/6. Actually, why did I do all that? I made that really hard. I didn't mean to do that.
I just did 3x equals 1/2.
Yeah, we should have just said 3x equals 1/2. That would have been the smarter play. Still got the same answer, but for whatever reason, I just saw let's evaluate this, and I was still able to do it with some of the same skills, but it may not have been the most efficient. That's okay. All right, this guy's pretty tough. Number 17 is probably the hardest one for most people.
I have a question.
Yeah.
So, oh wait, no, right, I got it.
Okay, the problem with 17 is this one's already solved for x, but it wants us to come up with an answer without a calculator. So most of the time without a calculator, it's going to be a nice whole number. This one just is not. So let me ask you this. X equals 1. Would this answer be too big or too small to be possible for this one? Too small, because if this was 8, that would be the answer, right? What about if the answer was 2? Okay, because 8 squared would be 64. And 16 is way big, or way less than 64. So I know my answer is probably closer to 1 than it is to 2. It's somewhere between 1 and 2, which is how I know that there's a fraction there. But this is the way that I think is the best way to approach this. Force yourself to say, I eventually want it to be 16. What if we tried to break this down into a smaller number? So like, let's say we raised it to the 1/3. Raising to the 1/2 is like a square root. Raising to a 1/3 is like a cube root. So the number times itself, that gives you 8, would be 2. So by raising to a 1/3, I'm able to change the 8 to a 2. Now, what can I raise 2 to get 16? Okay, so I really want to raise it to a 1/3, and I want to raise it to the 4th. So the answer to that question is 4/3. Now I guess you could also just try some guess and check with numbers. Probably going to be in the middle or a 1/3 like this. It's not going to be something super weird. But splitting it up like that, breaking 8 down to a base of 2 with an exponent of a 1/2 or a 1/3, square root, cube root, and then once you get it to a smaller number, it's usually a lot easier to see what the second half is. But multiply those to get 4/3. Okay, so same thing. On worksheet 2, probably the same question in the exact same spot. We'll need a similar approach for you to practice. Okay, now we'll review the stuff from notes part 1 that we did after the quiz last week. You definitely need to know the inverse of 2 to the x is log base 2 to the x. That's why we're doing logarithms after exponentials. That's why all textbooks are set up that way, all math textbooks. If you're asked to graph something like this, you should probably say, well, it's going to look like log base 2 of x shifted left 4. So that's the transformation. And how you're supposed to know what this looks like? Well, one, it's nice to know what a sketch of it looks like. All the logarithm graphs look like this. But to be accurate and get some points, this is where the last 2-3 weeks worth of work has been helpful. If 2 to the x is its inverse, graph 2 to the x. Two to the 0, 2 to the first, 2 squared, 2 to the third, etc. This is the exponential function that you quizzed over last time. Because this is its inverse, switch x and y. 0, 1 becomes 1, 0, 2, 1 becomes 2, 1, 1, 2 becomes 2, 1, 2, 4 becomes 4, 2, 3, 8 becomes 8, 3. So not only does that help you discover what log base 2 of x looks like, you've got some exact points. I'm sure it goes through those exact points. Now, to deal with this left 3, it's not a big deal because I'll just shift a bunch of points left 3. Or 4, left 4. And then reconnect. And that's what f of x is supposed to look like. So these questions are very similar questions, most of them are, to what we did with exponentials. Domain, describe the x values. -4 to infinity. Range, describe the y values. -infinity to positive infinity. The asymptote was at x equals 0, but then I shifted it left 4, so x equals -4. We did a few of those in the notes without even graphing, but it's also right here. It's a vertical line, so it has to have a vertical equation. That's why it's x equals and not y equals. Okay, x-intercept, I can see that it goes exactly through -3, 0. I knew that because it was at 1, 0, and then I shifted it left 4. That's why I really like having exact points. Y-intercept is going to have an x value of 0. So my graph looks like it's, I don't know, 1.5, less than 2, but that's not a good idea. This is just a sketch. Take your equation, plug in 0 for x, and solve. We couldn't solve that in the notes last time because we didn't know how to evaluate logarithms, but now we do. Log base 2 of 4 is really just 2. It should have gone through this point. I actually even had that point on my graph, I just didn't sketch it very good. Okay, and then same idea. It looks like it goes through 4, 3, but don't rely on your scan. Like, you could have a small mistake. Plug it back in up here. If I plug in 4 for x, I get this. Where am I getting base 3? Base 2. Okay, and then 2 to what power gives you 8? Well, that gives you 3. So plugging in 4 for x gives me a y value of 3. So I can check. Doesn't just look like it goes through 4, 3. By actually plugging in 4 for x and solving for y, I see that it's 3. And you can do that now that you can evaluate a logarithm. As long as you understand what it's asking you to evaluate, if it comes out to a nice whole number, then it's usually pretty straightforward.